This presentation is about resistance and temperature. In this lesson, we are going to learn to describe the effect of temperature increase on the resistance of a metallic conductor. Unsay effect kung magkataas ang temperature on the resistance of your metallic conductor. First, let us know that the current density is directly proportional to the electric field. So, ang kining electric field again, na-produce ni siya. So, going outward from a positive charge, going inward to the negative charge. And it says here that your current density is proportional to the electric field. Kung dako ang electric field, dako pod ang imuhang current density. Now, if they are in direct proportion, what do we mean with direct proportion? If we are going to convert this into an equation, we must introduce a constant. So, morning natay constant nga conductivity of the material. So, conductivity of the material is now the factor kung unsa kadako ang proportionality, no? Kung unsa kadako ang pag-increase sa J whenever E is increased, mo na siya ang conductivity. In the complicated case, this factor, the conductivity, depends on temperature. There is another way to express this since we're talking about introducing a constant. So, J, kung na kay proportionality, so constant times E, di ba? So, multiply constant times E. So, muna siyang equivalent sa imuhang proportionality relationship. So, instead of sigma, we could also have another constant nga instead of inaana sa sigma siya, himuon na siyang 1 over rho. So, muna gitawag na ito nga resistivity of the material. And in the complicated case, your rho is dependent with temperature. When resistivity is low, it means it is easy for electrons to flow. So, unsa nga ning resistivity? Kanang i-resist niya ba ang flow? So, yang pugnan ang flow. Dili niya i-tolerate ang flow. So, kung low ang resistivity, dili man yung pugnan, so sayon na ay ang pag-flow sa electron. Okay, so this is how we imagine high temperature. High temperature for metals means that the atoms are colliding or vibrating faster than kung nasa low temperature. So what happens kung fast ang collision? Di ba? Mo na siya ang init ng pag hikap nimo sa kaldero nga init, mapasok ka kay gipang sumbag sa mga init nga metal atoms ang imuhang finger mo nang mapasok ka mamula siya. Okay, unsay mahitabo karon? So ang imuhang mga nagkuan sila didto, nagbinanggaay sila. So mura ba siya og traffic nga kung sige og bangga, unsay mahitabo? Nga na traffic na nihinay na ang dagan sa mga sakyanan, nihinay na ang current flow. So it means that for metals with temperature increase or more collisions, it will disrupt ihang i-resist ang electron flow. Therefore, resistivity increases. High temperature, the more nga mo resist siya sa flow. Kay nga no, sige magpangbangga ay. So na traffic na noon og samot. Okay? So it's like that. So for metal, resistivity increases with temperature. For a semiconductor, daghan pa man nagklase nga materials good. Sa uban nga materials lahi because resistivity decreases with increasing temperature. And for a superconductor, so at first kanang inani pa siya no, the more nga i-lower nimong temperature, dili na siya mo resist. Kini may grabe. Mo nang gitawag siya superconductor nga ipag-lower nimo sa katong negative 273 degrees Celsius, ang mahitabo niya is wala ni resistance. Kung unsa ipa-flow ni mga current, flow gid siya kayo. Okay? So, this is how we put this into an equation. So, this is your This is your resistivity before the temperature increase, and this is your resistivity after the temperature increase. Notice the notation. Kung mayon ta ginana, dili ni siya times, so not multiply. What this means is rho is a function. Rho is a function of temperature. Okay? So mo ni pasabot na to din sa left side. That rho is as a function of temperature goes like this. Kung unsa ang temperature before the increase, madungagan siya og katong original nga kuan nimo, resistivity, multiplyan nimo og katong temperature increase times multiplyan pag nimo og constant nga gitawag nato og temperature coefficient of resistivity. And here are the numbers, the values for your coefficient of resistivity, temperature coefficient of resistivity. So muna siya ang mga values. So notice na isa diri nga negative. Mostly positive sila tanan. So naa puday uban nga cases nga kung na-decrease in temperature, ayha pa mo increase ang temperature. Okay, so again, put this in mind that when it's higher temperature, more traffic, less flow. Less flow, therefore, more resistance or katong taas ang resistance. So, and since resistance is directly proportional to resistivity, makita natin sa next lesson, then muna siya. So, ang imuhang resistance is inani po ang ihang form nga. Ang resistance of your noun of the change after the change in temperature, mahimo na siya ng nani. Katong initial ni mga resistance plus katong i-multiply nimo ning tulo. Initial resistance times temperature coefficient of resistivity times the temperature difference. So notice kung i-decrease nimo, so makuan pod kining maunsa pod siya. Ma-minus pod ang resistance mo, gamay pod siya. Unless kung ang alpha nimo is negative, just like atong carbon. Atong ipakita ganyan. So, that's it.